Hi, today I'm going to continue with my project, my PCB Business Card project, and as you can see behind me, it is already done. I just have to do the routing, and I published this project in the EEB blog, and because I wanted to ask for feedback, both positive and negative, and some people give me positive feedback, they liked this project. And some others told me that I should change the kind of connector that I'm using, don't use a real connector, use a PCB connector. And this is, if someone takes my PCB Business Card and connects my PCB to their computer and something fails, it will be something bad about me because I designed something wrong and that ruined their computer or something like that, or they may think that my PCB has some malware inside it. So it is okay, it is possible they think so, but I think people is smarter than that, and I like the kind of connector that I'm using because it's a real connector, and the thickness of my board makes it impossible to use a PCB USB connector. I don't know if you understand what I'm saying, so I will put a picture here in order that you can see the kind of connector that they say that I should use. But I'm going to stick with my USB connector, my real USB connector, because I love this kind of connector, and it is mounted in a slot in the PCB, and it's very nice. And I think I don't care about the cost. I know that this is very expensive. It is more expensive than the other solution. The other solution is cheaper, but it will force me to change the shape of my card, and I don't like that. I prefer to stick with my USB connector. And today I'm going to show you how to check the footprints, because I already did that, but I'm going to check the footprints, all the important footprints in my design, and I will show you how to do that. And I will do the routing, and I will speed up the routing while I am doing, so you will see me routing all the board. And then after the routing and all the process, I will send this to manufacturing, to Itead Studio, so you can see how you should generate the Gerber files and all that. So I hope you enjoy it. I think this is going to take some time, but I hope you like it. So let's begin with this. Thank you. Okay, here I am in Itead Designer, and this is my board. The components placement is the one that I'm going to use, and as you can see, there I have a QR code, and this QR code will send you to my About Me page. I don't know if you know that website. This is my About Me page. It is not finished, and this is raw English. I have to translate it better. And here you can put links to whatever social network you want. So there is links to my video blog and all the usual stuff. So because I thought that this QR will send you to my video blog, but that is redundant, because my memory card in this PCB Business Card already will have a link to a presentation video, and you will see me talking and presenting myself. So I think it's better that this QR code sends you to something like this, and then inside the flash drive, the memory, put a link to my presentation video. And that is what I'm going to do. And by the way, you cannot see this in gold,
because I didn't put the ground planes. So here is the real view of my PCB, but this is the 3D view, and this is the back side of my PCB. You can see here the instructions and how to read the temperature. This is the Euler's formula and the electrostatic discharge logo or icon, and this is the date in which I finished more or less all and those holes are for a necklace. You can use this board as a necklace, and this production code will be for well, Itead put some code in the boards that you sent to them when they manufacture them. So I left this space for them to put their manufacturing code. I hope they will use it, because I don't want them to stick their stupid code somewhere in front of my board, because that will ruin my design. And I forget to show you my schematic, and nothing has really changed. I have my 3.3 volts regulator, my USB connector, my reset circuit, my crystal oscillator, my LEDs, my red, green, blue LED, my temperature sensor, and my in-circuit serial programming interface, and as well my memory, and of course my PIC microcontroller. And I have this differential pair for the USB, and it is a differential pair, and you should route that correctly. And I'm going to do it wrong, because if you are doing some serious USB stuff, you should take you should have in count all these kind of things. Okay, here it is. Some common routing mistakes. Okay, you should have in count all of this if you are doing serious USB stuff. But this is a specification for high speed USB, and my design will be full speed, that is 12 megabits per second. High speed USB is for 480 megabytes per second. So that really doesn't care, but the mistake that I'm going to do is this one, stubs, because I have to route my differential pair to the USB connector, and then I have to route that to my in-circuit serial programming, and that will create two of those mistakes, and that is not going to be 100% correct. But this is for very serious USB stuff, and I don't care about that. It doesn't matter. My circuit will work finally. Okay, so to print the footprints and the layers that you want, you just have to go to files and print preview, and then you have to set the page setup. Well, you have to set the scaling for 1, because if you set that to other things, your components will be distorted. They will not be in the real scale. So you should check that your printing is scaled to 1, and then set to print configuration. I think yes, you have to select the layers that you want to be printed. For example, insert layer, if we want to print the top layer, the bottom layer, mechanical one, top overlay, and all the usual stuff. You should check that. For example, I don't want to, yes, yes, bottom layer is okay. So, okay. And Altium Designer will show you how you are going to print that. And as you can see, this is a very nice setup to check if my footprints are correct. And what I'm going to do is to print that. But before that, I think that I'm going to add the board shape. So insert layer and keep out layer. Where is it? Keep out layer. Okay. Yep. Here's my. Oh, but I didn't correct that. I think, or yes, I did it. I did it or not? Well, let's print it. I will fix that later. I don't care right now. So print. Okay. And now when we have this printed, we have to check the size of the components. So let's do it. Okay, here I have the printed page, and here I have some of the components that I'm going to use in my design. So what I'm going to do is check some of them, because I already checked I already did that for each component. So for example, I'm going to check if my big microcontroller will fit here, and you should check if the paths are the correct size, if everything is fine, and if they match everything in your footprint. Okay, for example. Okay, so as you can see, my integrated circuit fits nicely. This is a PIC microcontroller, and you should see if your paths fits correctly here and all the usual stuff. And I'm going to do the same for my oscillator. This is my oscillator, my 12 megahertz oscillator, and as you can see, that one fits nicely. Oops. And same for this memory. This is my 2 megabytes memory, SPI memory, and this one will be here. Okay, everything is nice. And you can see here the paths and the thermal path should be all nice. And this is my 3.3 volts regulator. This is a microchip part, a microchip component. Microchip is famous for their microcontrollers, but they do very nice and cheap analog parts as well. Whoops, I'm having a little bit of trouble with this component. And this one will be what the hell. Okay, and this one is my USB connector, a mid-mount USB connector, and that one will be right here. Let's see if I can take a coin. Okay, this one is a €1 coin. This is my oscillator. This is my
PIC microcontroller. This is my 2 megabytes memory integrated circuit, and this is my 3.3 volts regulator. And as I said, I'm not going to check the LED and the resistors and capacitors because those are standard, and I don't care about that ones because I already checked that. So this is how you should check your footprints. But remember, this page printing should be in one by one scale, in the real scale, because if you use any other scale, obviously it is not going to match your component size and all that. So now that we already checked the components size and their footprints, we can start by doing the routing. So let's begin with that.
And before you start routing as a monkey, you should take in count each of everything of this information, your manufacturing capabilities. So I am in the Itead Studio page, and here I have the PCB capabilities, and you should have in count all of those things. And because many people is using this company, I already found some guy that used those DRC parameters, and you should configure your Altium Designer DRC design rule checker for those parameters in order to avoid mistakes and the usual stuff. So do that before start your routing, and now I'm going to start routing. once you have finished your board, you should check that everything is correct, everything is fine. You can do so through the design rule check. Here, run design rule check, and Altium will check your design rules and tell you if something is wrong. I have 50 rule violations, but I checked those ones, and it is there is nothing very serious, and I'm going to send this to manufacturing. I already did that, but I'm explaining you how to do it now. So what you have to do is generate the Gerber files, but let me show you how to do it for Itead. You should go to the Itead web page, and you have here a lot of services, and you should select the one that you are going to use. For example, I'm going to use a 2-layer design, and I'm going to use a color solder mask, not the green, and my board is bigger than this one, so I'm going to use this one, this service. And of course you should select which you know, you should check your characteristics, your PCB characteristics, and here this is explaining you how to do the design and all the stuff. So you just have to follow this point. Gerber files needed for 2-layer PCB boards. Okay, so we need to generate the top layer, the bottom layer, solder stop mask bottom, silk top, silk bottom, and the NC drill. And somewhere over here tells you outline or shaped should be included in at least one layer. Okay, and here it says that you cannot panelize your board using holes or slots. You should do it with a silk screen, because they are not going to do slots or holes for you. So you have to do this way. It's very ugly. It's a very ugly way to panelize, but yeah. So we are going to generate the Gerber files. Gerber files must be RS274X format, and the way you do so in Altium Designer is through Files, Fabrication Outputs, Gerber files, and you should select the format that is good for you in base of this description here. 2.4 is normally enough for everything, and you should select your layers, the Gerber files that you want to generate. So we need top overlay, top solder, top layer, bottom solder, bottom overlay, and keep out layer is my board outline, so I'm generating that one. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6, 7. Okay. And okay. And now it is generating the Gerber files. Here you can visualize your generated files. As you can see, there is no holes. So this is the complete design, but now we have to generate the whole files, and you do it through fabrication outputs and drill files, NC drill files. Okay, we want that one, blah 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 blah. Okay, Okay. Now Ultima has generated our holes, and we can import that file here. File import Gerber. Oops, Gerber no. File import drills, and okay. Okay, and as you can see now our board has holes, and you should check if everything is correct, if everything is good and fine. Okay, I'm happy with that. So now what you have to do is proceed to check out your board. It is very easy. I'm not going to do it here, but you have to pay, and then they will send you an email like this one with your order code, and it is very simple. You just have to follow these instructions how to make your design fabricated. It is very easy. Here is explained. You will you will find you will send to them a message like this one with a zip file with all your Gerber files, and I already did my message, and I added this information because I want them to use this space here for the production code. So I'm explaining them that in my email. Hope they will read it, and after you send this email, they will send you this one. Hi, thank you for choosing our PCB prototyping service. We have received your Gerber file, and the files have been submitted to the factory for auditing. During auditing, if there are any problems or have questions about your design, our colleagues will contact you via email, blah 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 blah, and then they will fabricate your PCB, and they will send your PCB to you, and that is how you do it. It is very easy, I think. Luckily, in a few weeks or in 1 month maximum, I think I will receive my board, and I will do another video blog showing my board and checking if everything is correct and on all that. So thank you very much for watching. See ya.